Assalamualaikum and a very good morning to Doctor. First of all, let me introduce myself. My name is No3 Anis binti Muhammad. Metric number is 58484. So this is my video assignment about the complex compound. So I choose a complex compound, which is a carbonatotetraamminecobalt 3 nitrate that I choose from the journal Science Direct. So this is the structure of the metal complex. So this is a oxidation number of the metal ion. I calculate the cobalt, metal cobalt, and I got CO3 plus. So this is a ligand name that attached to the metal center, which is ammonia, carbonic ion ligand, and nitrate ion. So ammonia ligand NH3, which is a strong field ligand and pair up the lone pair electron. Ammonia is a monodentate ligand, and ammonia also a neutral ligand. So for the carbonic ion ligand CO3, carbonic ion act as a bidentate ligand because it can form a bridge between the two metal ion. And carbonic ion is also strong field ligand with the negative. It is a negative charge ligand with the charge negative 2. So for the nitrate ion, is a monodentate ligand. NO3 is a weak field ligand and it is a negative ligand with the charge negative 1. So the complex name in the formation of the carbonatotetraamminecobalt 3 nitrate denoted as a CO and H3 4CO3NO3. The transition metal which serves as the central atom is cobalt. Its first coordination sphere of everything directly bonded to the cobalt is 4 nitrogen atoms and 2 oxygen atoms. This coordination sphere represents in the chemical formula with bracket. Because cobalt involved in 6 bond, its coordination number is 6 and the structure around the cobalt is octahedral. So let me proceed to the name and preparation of the complex compound. The name of the process is hydrothermal decomposition. So a typical experiment for the preparation of the CO3O4 hollow sphere is follow. First, 2 grams of CO and H3 CO3 NO3 powders were added into 25 ml of deionized water. The prepared suspension was stirred at room temperature for 10 minutes and transferred into the 50 ml Teflon-lined stainless steel autoclave and then put into an oven to keep at an appropriate temperature, which is 140, 160, and 180 Celsius for 2 to 6 hours. After cooling down to room temperature, the obtained black precipitate was collected from the autoclave and washed for 3 times with deionized water to remove any impurities. The washed product was dried in an oven at 60 Celsius overnight. In order to make a comparison, 2 grams of CO and H3 CO3NO3 complex was calcined in the electric furnace at 180 Celsius for 2 hours. So this all the process for the preparation of the complex compound. So let's proceed with the Alton symbol with microstate table. So this is a microstate table that I calculate, and I get 13 term symbol, and all of this I put into the report, and all the calculation I have done and I put into the report. So let me proceed into UV-vis spectrum. So the optical absorption properties of the as prepared CO3O4 hollow nanosphere were investigated at room temperature by UV-vis spectroscopy. So there are two obvious absorption bands in 250 and to until 325 and 375 to 60 nanometer wavelength range. CO3O4 is a p-type semiconductor and its optical band gap can be obtained from the following equation. AHV 2 equal to BHV minus EG, where A is the absorption coefficient, HV is the photon energy, B is a constant relative to the material, EG is the band gap, and N is either half for an indirect transition or 2 for a direct transition. So the AHV2 versus HV curve for the product is shown in the inside of figure. So the value of the HV extrapolate to A equal to 0 give the absorption band gap energy. Two regions with a linear relationship are observed given two EG value of 2.2 and 3.6 eV. So as have been investigated in the lecture, and the band gap of 2.2 eV and can be associated with the uh, oxygen to CO3 charge transfer process valence to conduction band excitation, while the 3.6 eV band gap relate to the oxygen to cobalt 2 charge transfer. The former bend tail into the visible region and disappear around 600 nanometer. The visible light photocatalytic activity of CO3O4 hollow microsphere could be attributed to the existence of this broadband with the band gap of 2.2 eV. So let's proceed to the last slide, which is application of complex compound. So the application of the complex compound that can be obtained is for the gas sensing and drug that are processed in laboratory, and it is also important for the construction of high performance capacitor and hybrid batteries. So that's all from me. Before that, this is all the reference that I refer, and I give a credit to the Dr. Mohammed Waisul Karni bin Osman. That's all from me. Thank you.